Oh, hi. Thanks for showing up for your learning. At this time, we're going to look through applying transformations to various functions. So I want you to approach these problems in this way, where we first start by identifying the parent function. In the case of g of x, the parent function f of x is just a reciprocal function, so it's 1 over x. And then describe the transformations verbally that have been applied to it. So in this case, our transformation, let's get that big box out of the way. So we're just going to go with a bigger font here. And then we're going to say, well, this first reflect in the x-axis and stretch the function vertically by factor 2. And this is a result of the a value being equal to -2. That -2 creates the reflection in the x-axis and creates the vertical stretch. And we see that that's there. Sorry, no, go away. That's a result of this a value here. Okay, and then what about this -3 and this +5? Okay, well, let's describe those transformations. They're both translations. So this is translate the function to the right 3 units. And that's the result of d being equal to +3, because d is a sign flipper, and then translate the function upwards 5 units. That's a result of c being equal to 5. So you want to be able to look at something like that and analyze it. And then after you've analyzed it, you can go ahead and graph it. All right. So it also says, so I've described the transformations that have been performed. And now let's create a table of values for the parent function and graph the transform function working point by point. What is that going to look like? Well, I'm going to create a table of values for the parent function. So this is x and this is 1 over x. I can memorize these tables of values if I want, or I can just choose nice x values, particularly maybe values that might fall in this range. So I might look at -5, and then the reciprocal of -5 is -1/5. And then I might look at -1, and the reciprocal of that is -1. And then I might look at -1 over 5, and that would go to -5. And then I might look at 1/5, and that would go to +5. 1 would go to 1, and 5 would go to 1/5. Okay, so there's a table of values for the parent function. If I'm working point by point, I want to create a transformation point so that this would all transform over. You don't need to do this in two different colors, but you can if you want. I know that in these cases, xy in f of x will map to x divided by k plus d, a multiplied by y plus c. So in this case, there's no k, but there is a d, so we're going to have x plus 3, and then our y values are going to map to -2y plus 5. And then I can just convert point by point. So -5 would go to -2, and -1/5 would become +2/5 when I multiply by -2 plus 5. Well, that would be 27 over 5. 27 over 5, I can feel you saying, what the heck is 27 over 5? Well, that's equal to 5.4. So when I put that onto the graph, I can think of its decimal expansion as 5.4. -1, -1. Well, -1 plus 3 is 2. And then, and then -1 times -2 will be +2. And then that will be plus 5, so that's 7. -1/5, well, I add 3 to it, so it's 2 and 4/5. So that's going to be 2.8. 2 and 4/5 equals 2.8. And then the -5 here Well, I multiply it by -2, so it's going to be -10 plus 5 is 15. It's going to be a little bit off my graph, but I can still kind of get it in there. All right, and then let's keep going. Okay, that was, now let's do 1/5. So 1/5 plus 3, that's going to be 3.2. That's 3 and 1/5. And then here, -2y plus 5. So -2y, that's -10 plus 5 is -5. And then 1, 1, well, that's going to be 4. And 1 times -2, so then just take this one, put it in here. 1 times -2 is -2, plus 5 is 3. And then the last one, 5 and 1/5. Well, that's going to become 8. And the 1/5 is going to become -2/5 plus 5. So -2/5 plus 5 is 4.6. It's 4 and 3/5. Okay, so 4.6. So now I can just graph my new table of values. So let's put these values onto the graph. All right, so I'm going to start with -2, 5.4. Here's -2, 5.4, about there. All right, and then 2, 7. So there's 2, 7. All right, and then 2.8, so we're a little bit over, and already up to 15. So 15 would be up about there. Gives me an idea of the shape. All right, and so this is the one component of it. It comes down here, very close to the asymptote, goes through this point, goes along here, and goes off towards that asymptote there. All right, and then so that is all of these points graphed. Let's graph these other points. So 3.2, -5. So 3.2, here is 3.2, -5, just down here. And then 4, 3. So here is 4, 3. Wow. Did I make a mistake? 3.2, -5. Let's check this one here. So if I have 1/5 and I add 3 to it, that is indeed 3.2. And then if I have 5, multiply it by -2, that's -10, plus 5 is indeed -5. So just a little bit surprised there. 4, 3, let's check that one. 1 plus 3 is indeed 4. And 1 times -2, yeah, those are all correct. Okay, I'm just seeing shadows or something. Okay, let's keep going. Now the last one is 8, 4.6. So let's graph this point here, 8, 4.6. Here is 8, and then we have 4.6, almost up there. All right, so this goes like this, turns, and comes diving down here. Okay, so there we go. That's been graphed. Another thing that you can do with this one here is to remember that the domain and range will also change. So the domain of this one is x is not equal to 0 and y is not equal to 0. These give us our asymptotes for the parent function. With the new function, those asymptotes change according to d and c. So here we move it 3 units to the right and 5 units up. So we have new asymptotes here that are, and we can see here, x is not equal to 3, because that would create a contradiction there. And y is never equal to 5, because this is always non-zero. All right. So here are our new asymptotes, and we'll see that we did a really good job of graphing those already. There's an asymptote there, and here's an asymptote here. So we see that this function can never approach, is approaching these two lines but never touching them. Okay. And so that's a really good graph of that function. Okay, let's take a look at this one. All right, first let's summarize the transformations that have been applied. And we start with our reflections and our stretches. Let me move that down here. There. Okay, so reflect the function in the x-axis and stretch vertically by factor 3. Okay, that's a result of a being equal to negative 3. And then reflect in the y-axis and compress horizontally by factor 1/2. That's a result of k being equal to negative 2. Okay, and we remember that well, the negatives are going to reflect, but k squeezes, so it's a functions like it's reciprocal. And then here, now translate the function 5 units right. That's a result of d being equal to 5, and translate the function 8 units upwards. That's a result of c being equal to 8. Okay, so now let's graph it visually rather than working point by point. We can work more visually with this one. We've already done the point by point requirement. I remember 1 1, 0 0, 1 1, 4 2, and 9 3 were on the parent function. So there's my parent function. Okay. So let's see. I'm just going to grab this. Move it down so that we can see it a little bit better over here, and then I can zoom in. Oh, there we go. Okay. So now let's, if we reflect it in the x-axis and stretch it vertically, then we're going to have, we'll do this one in orange. So we're going to reflect it vertically in the x-axis and stretch it by factor 3. So that's going to go to 6. And this 3 is going to go to negative 9. So that's after we apply the A transformation. It's going to look like this. Okay. And then we reflect it in the y-axis and compress horizontally by factor 1/2. So this is going to come over here and then be compressed 1/2. This 4 is going to come over here and be compressed by 1/2. And then this one is going to come over to negative 9 and be compressed by 1/2. So it's going to be negative 4.5. So now it's there. Okay. So now it looks like this. That's after all stretches and reflections have been performed. And then we just translate it 5 units right and 8 units upwards. So triumphantly in purple, we're going to do a little thicker pen. A really nice thick line here for our new function. Okay, and so it's going to be over 5 and up 8. So it's going to start there. And then we go over 1/2 and down 3. And then we go over 2 and down 6 from the beginning. And then over 4.5 and down 9. So it's going to be there and down 9. So we are at there. Okay. And so this will be our new function, something like this. I could find some more points if I want to get this area more accurate, but I'm already pretty satisfied with that, working more visually. Yeah, so that will be our new function. This is g of x. Just label that function. Because I've got a lot of stuff, this might be, I might label that f of x, the parent function. And then I've labeled g of x. Oh, I should have called it h of x, because this question called it h of x. And so that's how I would approach a question like that without using a table of values, just working visually. I'm still applying my point-by-point ideas, but I didn't really prepare a table of values. Okay, the last question. This question, remember, this is on the rubric, you'll see this is an important topic. It's worth 20 points overall, and I have a challenge problem baked in here. Because this is on a rubric, this is like, it's not most of the marks, even though it's the hardest question. It's to determine, like, did you get a 16 out of 20 or a 20 out of 20, if you can handle this type of question here. So this is like low level 4, high level 4. So in this question, we want to take this function f of x and transform it and then find out all the things about the new quadratic function. Okay, so let's go. I know that I want to reflect in the x-axis. So that's going to mean a is less than 0. Okay, vertical compression by factor 1/2. So that actually tells me that a is equal to negative 1/2 because I want to reflect in the x-axis and then compress vertically. Horizontal compression by factor 1/2. K will compress horizontally when k is equal to 2. So that's going to squeeze it. So that's going to be your horizontal compression. And then we're going to translate this thing 4 units upwards. So that's c is equal to 4. Okay? So now I can go from f of x, and I can say, well, I want to create a g of x, which is a new function, Raming's function, is equal to negative 1/2 f of 2x plus 4. Okay? That's going to include all of these transformations. And now I can evaluate what the equation of this new function will look like. So let's go. So I know f of x. I'm just going to copy f of x out here. F of x is equal to negative x minus 5 squared plus 9. Let's go. So I'll move me over here. Zoom in a bit. And let's go with a thinner pen. All right. So now, g of x, this new function, is going to be equal to negative 1/2 multiplied by negative, and I put in f of x here, but instead of f of x, I want f at 2x because of this k transformation. So it's going to be 2x minus 5. I just substitute in 2x for x wherever I see it, so I put in 2x there, squared plus 9, n square bracket plus 4. Okay? So that was just substituting in f at 2x here inside this square bracket. All right, let's keep going. All right, so g of x is going to be equal to, let's expand this and evaluate it a bit. So that's going to be negative 1 over 2 multiplied by negative 2x minus 5 times 2x minus 5 plus 9 and the bracket plus 4. Okay, just expand this exponent. And then I'm going to factor out the 2 out of both brackets to get it back into vertex form. So it's going to look like this. This is equal to negative 1/2 negative 2 multiplied by x minus 5 over 2 multiplied by x minus 5 over 2 multiplied by 2. I had to take out 2 once and twice. Okay. So this is 2 coming out of that bracket, went there, and 2 coming out of that bracket, went there, plus 9, plus 4. Okay, this is all equal to, let's move over here to avoid working on the graph, negative 1 over 2 multiplied by negative 4 x minus 5 over 2 squared plus 9 plus 4. All right. Now, let's distribute this negative 1/2 into the bracket. Negative 1/2 times negative 4 will be 2. So this is 2x minus 5 over 2 squared. Negative 1/2 multiplied by 9 is negative 4.5. And then plus 4. Look at me using a decimal, just like a student. All right, and then this is all equal to 2 multiplied by x minus 5 over 2 squared minus 1/2. Okay, minus 0.5. All right, let's graph it. I know that its vertex is at 5 halves, which is 2.5, negative a half. So its new vertex is right there. Okay. It has a stretch factor 2. I wonder what its roots are. Actually, I happen to know its roots are here and here. They're integers. Boop and boop. Okay. Why is that? Oh, I could tell you a step pattern, but it would be really complicated. I'll hold on one moment. Okay, so I might. Oh, so how would we find the roots of that? Well, we could factor it, or you could use quadratic formula, or you can just notice that when x is just notice, he says. Let's just find the other things. Okay, so what do I mean? Just find the other things. I should show you how to find these roots. My goodness, let's expand it into standard form and apply quadratic formula. Okay, so that's one way that you could do it. But you could also, when you expand this to standard form, find that it is factorable, um, and that's great. So let's put it into standard form. How about this is 2 multiplied by x minus 5 over 2 times x minus 5 over 2 minus 1 over 2. And having it in standard form is just going to be really useful because it's also going to tell us the y-intercept. So this is equal to, we're going to FOIL this, 2 multiplied by x squared minus 5 halves x minus 5 halves x is minus 5x when we put those together. And negative 5 halves times negative 5 halves gives you positive 25 fourths. Minus 1 over 2. Okay? And then this is equal to 2x squared minus 10x, and then plus 25 over 2 minus 1 over 2. So 25 over 2 minus 1 half gives us 12. So this is 2x squared minus 10x plus 12. So 12 is our y-intercept, so put it on there. Boop. And then let's find the zeros of this. This factors into 2 times x squared minus 5x plus 6. And notice that numbers that multiply to plus 6 are, this is equal to 2 multiplied by x minus 2 times x minus 3. What did I tell you? These are the roots. Boop, boop. So there we have all the things that we need on our graph. This comes down. Let's see what it is at 1, just so we get a nice point there at 1. If I put 1 in here, okay, so let's find g at 1 is equal to 2 multiplied by 1 minus 2 times 1 minus 3. So that's equal to 4. I just put in 1 in for x into that equation. And this is negative 1 times negative 2. So 2 times negative 1 times negative 2 is 4. So that's up there at 4. And by symmetry, that's there. And then this one is over here. And we can now graph our function. Sound effects optional, but highly encouraged. There. So that's a nice graph of it. And then let's label all of our key points. So this is the point 0, 12. This is the point 2, 0. This is the point 5 over 2, negative 1 over 2. That's the vertex. And then this is the point 3, 0. Done. All the things finished. So that's how you could tackle a question like that and find out Raming's new function. Bye for now, everyone. If anyone has any questions, hit me up by email. Find me soon. Bye now.